Assalamualaikum and a very good morning. My name is Manorada, and in this presentation, I would like to present our project, AgriScan. So, AgriScan is an AI-powered system designed to help gardeners and plant enthusiasts to identify plant species and assess their health by using computer vision and rule-based logic. AgriScan provides an innovative solution to assist users in identifying plants and diagnosing their health, making gardening more accessible and efficient. So the problem that we are facing are identification difficulties, disease detection, and unreliable information. For identification difficulty, we notice that many plant species look strikingly similar, making it hard for new gardeners to tell them apart, which can lead to misidentification and improper care. And for disease detection, identifying diseases or nutrient deficiencies early is very crucial, but it's not as easy. Often, by the time symptoms are visible, the plant may be already too far gone to recover. And for unreliable information, a common problem faced by gardeners is the overwhelming amount of conflicting advice available online. When users search for care tips, they often encounter inaccurate or generalized suggestion, which can lead to plant death due to improper treatment. So we are proposing AgriScan to basically help with plant identification, health diagnosis, and even actionable care recommendation. For plant identification, using the camera on your mobile device, the application AgriScan captures images of the plant and uses computer vision to accurately identify the species. For instance, distinguishing between a tomato and a succulent. This reduces the confusion for beginners. For health diagnosis, AgriScan detects visible health issues such as black spots, yellowing leaves, or abnormal growth pattern, helping users identify diseases or nutrient deficiencies before they become severe. And the last solution is actionable care recommendation. Unlike generic advice found online, this AI system, AgriScan, uses a logic-based expert system to provide specific, actionable care recommendation. For example, if a plant has fungal symptoms, AgriScan might suggest apply fungicide instead of just take care of your plant. So I will pass the stage to Shapina.
Now I will explain the knowledge representation and the key logic rules to use in our system. Agriculture affects everyone, and by using knowledge-based system, we can support smarter and more sustainable farming practice. And in this system, we use if the logic rules to represent agriculture knowledge. Rule 1 is for plant identification. If a plant has a red leaf and red fruit, the system identify it as a tomato plant. Rule 2 is focused on disease detection. If a tomato plant has black spot on its leaf, it indicates early blight disease. Rule 3 is related to nutrient deficiency, which is when leaf turn yellow and there are no spot. The system identifies this as a nitrogen deficiency. Lastly, rule 4 looks at environmental factor, which is if a succulent plant is in high humidity, there is a risk of rot. This rule allows the system to convert observation into meaningful conclusion that help with plant care and decision making.
Now, let's dive into the core logic of how AgriScan processes information using the state space search. To understand how our AI thinks, we define its journey through the three distinct phases, which are the initial state, goal state, and the search method. So for the first one, this begins with a raw image of a plant that is currently unknown to the system. Next, our agent will extract the visual features and traverse a decision tree to reach a logical conclusion. Lastly, the process is complete when the system provides a confirmed diagnosis and a treatment plan to the users. As you can see in our state space diagram right here, the search branches based on the input from two primary sources, the camera sensor and the environmental sensor. So, for the species recognition, once an image is captured, the system first will classify the species, and the next for the feature scanning. So, for the feature scanning, the agent then performs a visual feature scan. If it detects a spot or halos, it identifies a pathogen. So if we see yellow leaf with no spot, it infers a nitrogen deficiency. So for the last one, it will be the environmental context. For the plants like the succulents, the search also checks for the environmental rules. If the sensor reports the high humidity, the system will identify a rot danger. So lastly, the final step in our state space search is moving from the diagnosis to action. For the early blight, the prescribed action is to apply fungicide. For the nutrient deficit, it suggests applying the fertilizer. So for the environmental states like the rot risk, it instructs the user to reduce the watering. So as you can see in our uh, space search.
Hi, my name is Omar Aziz, and moving on to how our system interacts with the real world, we designed AgriScan as a goal-based intelligence agent. To define its behavior, we use the PEACE model, which stands for Performance, Environment, Actuator, and Sensors. So, first, the performance, P. Our main metric is accuracy. Thus, the AI accurately diagnose the disease. We also prioritize speed, ensuring the users get the results in seconds. Next, moving on to E for environment, the agent operates in real-world settings, a garden with a variable lighting and weather, while interacting with the user through the app. For the sensor S, the agent sees the world through the mobile camera to capture the visual data and receives command via the touchscreen. And lastly, A, actuator. Once a decision is made, the agent acts by updating the screen display with results or triggering notifications for urgent alerts. As you can see in the diagram here, this creates a continuous loop. The agent receives percepts, like the plant image, processes them using the logic rule we discussed earlier, and performs action like prescribing a treatment to help the users. So that's for intelligent agent. Uh, Next, I'm going to present about the proof of concept, the prototype demo. Okay, so to demonstrate how this theory works in practice, here is our proof of concept, the AgriScan mobile application. So first, we can see here that this is the screen for scanning, the sensing phase. When the user scans a plant, the computer vision model activates, and you can see here that the system is processing the image, extracting visual features like leaf shape and colors. This visualizes the state space search happening in the background. Next, the diagnosis report. Once the logic rules are satisfied, we reach the goal state. The app displays a clear diagnostic report. In this example, it successfully detects an early blight with 94% confidence. The treatment plan. The treatment plan, crucially, it doesn't just stop at identification. It acts as an expert consultant by providing a step-by-step treatment plan. The treatment plan, isolating the plant, applying fungicide, and trimming leaves. This directly solves the user's pain point of not knowing what to do after finding a problem. So, finally, in conclusion, AgriScan successfully bridges the gap between complex botany knowledge and everyday gardening by integrating knowledge representation to define disease rules, state space, state space search to navigate decisions, and intelligent agent architecture to interact with users. We have created a solution that is both accurate and easy to use. We believe this tool can significantly reduce plant loss for new gardeners and promote a greener, more sustainable future. That concludes our presentation on AgriScan. Thank you.